Okay, we have a little bit shorter lesson today, which I'm sure you'll appreciate. We're going to talk about basically one concept with two different names because it's got two different ways of looking at it, but it's a pretty simple concept. I think one you'll grasp fairly quickly. The idea today that we're talking about is midpoint and segment bisector. Let's start with midpoint. Midpoint is a very specific term. It refers to a point that is in the middle of a segment. Now let's think about that for a minute. Midpoint means a point in the middle. That's really shocking, isn't it? No, it's not. I mean, it's pretty obvious, and you're going to find a lot of names in geometry tend to be very descriptive like that. But again, I just want to point out a couple things. First off, do note that we have our little red tick marks there indicating in our drawing that those two segments are congruent or that they have the same length. And again, you'll see that kind of written out here. And that means that M is the midpoint of segment AB. Now, important to note, only segments have midpoints. Rays don't have midpoints. Lines don't have midpoints because rays and lines are infinite. Segments are finite. They have a definite measurement, which means they can have a definite middle point. It doesn't make sense to talk about something infinite middle point because it's infinite. So only segments have midpoints, and here we see an example of that. M is the midpoint of AB. If I know it's the midpoint, I can conclude that segment AM is congruent to segment MB, or that the length of segment AM equals the length of segment MB. Again, those are things that you see written in your notes, and they're conclusions that you make. So again, we're going to be using these facts in the future to draw conclusions, so it's important to understand what it means to be a midpoint and what conclusion you can draw based on that fact that it's a midpoint. A segment bisector, as is written here, is simply something, a point, ray, line segment, or plane that intersects a segment at its midpoint. So anything that intersects a segment at the midpoint is called a bisector. Now, midpoints are only points. Bisectors can be anything from a point to a plane that's intersecting at the midpoint. It does the same thing. It still splits that segment into two congruent smaller segments, or makes the measurements of those two subsegments equal. Again, you see the little red tick marks that indicate congruence. Same ideas that we've had before. We've still got those little marks. And that's what a segment bisector does. Now, the application of this is really very, very straightforward. My encouragement, again, with you, whenever you're working on homework, whenever you're working with a picture, always, always, always label the picture, draw on the picture, redraw the picture, make sure you understand what's going on. Because it's way, way, way too easy to make simple mistakes when you're working with this just because you're working too fast. So slow yourself down, write on the picture, see what's going on. In the skateboard picture design below, VW bisects XY. So again, let's make sure we understand what's going on here. VW, this segment right here, is bisecting XY. So which one is being bisected? XY is the one being bisected, not VW. So, and we can see in our picture, it's all perfectly indicated for us. We have our little red tick marks there, so that helps us see what's going on. So that's the two, XT and TY are the congruent segments, or the length of XT equals the length of TY. Now, we're told that XT is 39.9, so let's label that. Well, if that's true, that means that TY also has to be 39.9. But let's answer our question now. Our question says, find the length of XY. Oh, it'd be really easy here to say, oh, 39.9, the other one's 39.9, we're done. But we have to look at the picture and say, oh, I want XY. Well, I want the whole thing. Oh, again, pretty obvious. Once we have that, that's going to be, what, 79.8? And that's how we indicate our answer. XY equals 79.8. Again, I don't want to just write 79.8 because I don't know if that means your body temperature after a long swim in a very frozen lake. what that 79.8 means. I need to know, oh, the length of segment XY equals 79.8. Notice it would not be appropriate to write segment XY equals or is congruent to 79.8. All right, that wouldn't be appropriate. Here we're just talking about the length. The length is the number, 79.8, XY equals 79.8. No segment symbol, no congruence. It's a number, so it's equality. Identify the segment bisector of PQ, then find the length of PQ. And again, notice they don't say find the length of PQ. It just says find PQ. And you have to understand when you see this instruction right here that what it's asking you for is the length of segment PQ. The lack of a symbol there tells you what it's looking for. And it's your job as the reader of the problem to understand what it is that's being asked for. If this shows up on a quiz or a test, and you'll say, well, what does it mean, find PQ? I will say that's what you need to know. The question, that's one of the things I'm testing you on, is do you understand what is being asked for by the notation of the problem? First, identify the bisector. So in my first segment here, M is by the indication of the little red tick marks. M here must be the midpoint. Again, we can assume there is a point where two lines or two rays or something intersect. So the bisector is MN, and MN in this case is a ray. And again, when we name the ray, we start with the endpoint and then some point along the way. If that's 1 7/8, and this also is 1 7/8, right to here, and it wants PQ, which is the whole thing. So PQ equals, we have to add 1 7/8 and 1 7/8. Now, if that's going to be difficult for you, go ahead and use your calculator. That's fine. You're welcome to do that. But that's going to be, what, 3 3/4. And again, since the problem is given to us as a fraction, we're going to leave it as a fraction in the answer. You're not going to change that. Here, the bisector is just the point M. And yeah, a point can be a bisector. It's the midpoint. The midpoint is a type of bisector. And then PQ is going to be 4 4/7. So pretty straightforward types of questions, little fraction practice. This is another typical type of question. Point M is the midpoint of VW. Find the length of VM. All right, you're saying, well, okay, that's great that M is the midpoint. I've got the little red tick marks indicating that they are congruent or they're equal measure. So what do? I have to set up an equation. So now I've got to start using my algebra skills. And we're going to do this all the time in geometry. We're going to use a geometric concept to set up an algebra equation, use algebra to solve, and then go back to geometry to interpret the solution. So these two segments have to be equal to each other, so there's my equation. 4x minus 1 equals 3x plus 3. Now, word of caution. We don't always just take whatever two algebra expressions we see in a problem like this and set them equal to each other. In this case, we did. But that's not always going to be the case. So every new picture is always going to need to be evaluated on its own merits. Don't get into the idea of just, well, we always just set things equal to each other. Because if you do, you're going to make mistakes about 3/4 of the time. You'll be right about 1/4 of the time, which is great. But it's not 25% isn't a great grade. So we solve our algebra equation, basic algebra stuff. I'm really fine with you doing more than one step at once, so long as you're showing your work for those steps. So if you want to do minus 3x and minus 3x and plus 1 and plus 1, all is one step, that is just fine with me. If you want to do it as two separate steps, that's fine also. But I do want you to show your work so I can see where your algebra is going with this. 4x minus 3x is 1x plus 0. The 3x minus 3x is 0. 4, x equals 4. Fantastic. But we're not done. There are occasions where it'll say find the value of x. and that'll be your problem, and once you found the value of x, you'll be done. But that's not what this question asked us. This question says find the length of VM. Now notice they said find the length of segment VM here. They could have just said find VM. They could have just written it find VM with no symbol, or save the verbiage there instead of writing the length of, because VM without a symbol there means the length of segment VM. So again, this entire phrase here means just this VM without a symbol there. It's a bit of a shortcut to write it that way. So if I'm going to find VM, I'm going to have to substitute this value of 4 back in to that. I know VM, oh sorry, that was a terrible V. I know that VM equals 4x minus 1, but I know that x equals 4. So that's 4 times 4 minus 1, or 16 minus 1, which is 15. So VM equals 15. And again, not terribly difficult to set up, but as you can see, we have to be careful as we set things up. We can't just dive into things. We have to think about it, look at the picture, analyze. Once we solve for x, is that my actual solution? See, geometry really makes you think. It makes you think about your problem. It's not like algebra where you just do a process, find x, and you're done. Do the process, find x, and you're done. Now we're applying the algebra that we learned how to do, and we're taking it to that next level. Again, identify the segment bisector of PQ, then find MQ. 3 and 4 are pretty much identical. We'll just go through one of them. Let's go ahead and choose number 4 for no other reason than it's number 4. So segment bisector, the bisector, I could say it's point M. I could also say it's line N. Either way would be okay. What I can't say is it's line MN or segment MN, because remember, N is not a point here. The small n here by the arrow is a name of the line, not a point on that line. So I'm going to say the bisector is line N. And now I need to find RS, which is the entire length. But in order to do that, first I have to solve for x. Again, since these two are congruent, I'm going to set up my equation. 4x plus 3 equals 6x minus 12. Show my algebra work. I'm going to subtract 4x from each side. This time I'm going to do it in 2 steps instead of 1, just as a different demonstration. 3 equals 2x minus 12. Add the 12. And I get 2x equals 15. So x equals 15 halves. Now I'm going to have to still go ahead and find RF. So RM equals 4 times x, which is 15 halves, plus 3. Now multiplying this, fortunately that reduces. That's 30 plus 3, so RM is 33. But RM isn't what I'm looking for. I want RS. Fortunately, if RM is 33, MS also must be 33. So RS logically must equal 66. So again, even though it's a relatively simple picture, relatively simple question, the amount of work that's necessary and the care that needs to go into that work is pretty significant. And again, that's pretty typical for geometry. That's our lesson for today. We'll be working on problems like that in class, and we'll be working on, that's only the first half of Chapter 1, Section 3. We'll talk about the other half tomorrow.